So, my name is April Edwards. I recognize a few of you out there from social media, my favorite stalkers. This gentleman over here in the middle row, I saw several years ago in person at a Visual Studio talk. I think it was Visual Studio 2019, actually, when it got released. So I actually sit here in the UK. I live right down the road. This is my home office, believe it or not. So I'm local to each and every one of you, effectively. I don't sit in the US. I know I sound funny. I am a Brit. They gave me a passport and let me stay. So I've been here almost 10 years. I'll be celebrating 10 years in January. But I am a senior cloud developer advocate, and I own the DevOps practice for advocacy. What does that mean? I do cool stuff with cloud, GitHub, Azure DevOps, infrastructure as code. I sit on a team that is kind of IT pro, cloud native focused. But my career is IT pro and in development. So I've done both sides of the fence. So DevOps was really natural for me. I hit a lot of technical problems in my career, and I said, well, DevOps is kind of the way. And it started with infrastructure as code. That was actually my thing that really opened up my career for me. So the first thing we're going to kick off with is DevOps. I'm going to talk a little bit about DevOps and DevOps processes. And I know you just saw the DevOps, GitHub, ADO stuff previously, but I want to talk about the process and the culture change. Because 80% of DevOps is going to be about people. 10% is tooling, 10% is process. So we're going to talk about tooling and automation, all these cool things, but there's going to be a cultural shift as well in the organization. So what is DevOps? I'm going to ask you all to be participatory and tell me how you would define DevOps.
No idea.
Great.
Automatic deployment and builds.
Okay.
Team collaboration tool.
Team collaboration tool. We talked about deployments and builds. Anyone else? Reduces risk, absolutely. And we've just had 4 or 5 different answers, and each and every one of you are thinking different answers in your head. Why? Because we have all different life experiences, backgrounds, technology stacks, et cetera, that help us build that definition of DevOps. But at Microsoft, we have a definition that we use every single day. DevOps is the union of people, process, and technologies, or tooling, to continuously deliver value to our end users. And I want to talk about this word value. I'm going to talk to you about tooling today. That is 10% of what we're going to talk about. There's a massive cultural change. But the word value is critical. So how many of you support customers in your day-to-day role? Yep. And they want to know what value they're getting for their money, right? So what we're going to talk about is this value aspect. Are we delivering value? So I don't care if you're in the operational space, development space, PM space. Are you delivering that value? So why do we care about DevOps? Because your competition's already doing it. I used to work for an MSP here in the UK. I won't name names. It took us 4 days to deploy a server for a customer. 4 days. How many of you would still be in business if it took 4 days to deploy a server? No one. Absolutely not. Yeah. See? That's the answer I actually like. We don't deploy servers. That's perfect. Unfortunately, we did. But also at the very bottom down point here, reducing human error. We make errors. We are humans. That's what we do every single day. Azure had an outage. This was a long time ago. I know Azure has outages more than that since then. Someone was changing something on a storage element in the cloud. It brought down the entire storage capacity. So why? Human error. So we want to automate as much as we can. So today we're going to talk about automation, infrastructure as code into Azure, and why this is going to be really good for you all. So bottom line, we also have stats to show why DevOps is important to organizations. It used to be a theory. Now we have facts. We're going to use some of those facts to help us deliver a high-performing organization. So at the end of the day, our C-levels want increased revenue, right? They want to be able to pay our bills. And we want faster time to market. So if your competitor is doing something that you're not, your customers are going to look to them. And I've done it as the MSP. Well, this company over here does X. Why can't you guys do that? And you're like sweating, right, in the customer meeting, especially when they're a 6-7-figure customer and you're sitting in London in a suit at a big investment firm. Not that I've ever been there, but I've had to have that conversation. And that's not a place I ever want to be again. But really important, there's some other stats around it. We know we have faster time from commit to deploy. We recover from incidences faster, and that's critical because we're going to have issues. We're going to have incidences. And our infrastructure as code is absolutely going to play into that. And then lower change failure rates. So these are all critical things that play into this. Now, how do we get these stats? These are all measurable output. So when I talk about infrastructure as code, one of the big things is having that measurable output, something tangible. Okay, we made a change. We've become a high-performing organization. How do we measure that? We change our KPIs in our organization to find these numbers. So maybe we're deploying more frequently. Maybe our 4-day deployment of our server, and bless the people over there not deploying servers, but a lot of our customers have servers. That's the reality of it. We take that 4-day, we get it down to 1 day. We get it down to 4 minutes. We make those improvements, and those are numbers we take back to the organization. So I'm going to talk about the people change, okay? Because this is the hardest part of DevOps. You have a siloed organization with operational folks and development, and they have a wall between them. Now, the other thing we have to think about is, how are these people incentivized? How are they driven to deliver that value within your organization? Take your operational teams to begin with. They need to keep the lights on 24/7 by 365. You're also probably delivering an SLA. So any change the developers make are going to bring down the infrastructure. So you get angry infrastructure people, and developers are going, well, hold on. We're incentivized to push new features. So these two things conflict all the time. So we're going to talk about all this tooling, all this great stuff. We need to incentivize our people to work together. We need buy-in from the top of the organization all the way down. If your executive team can lead by example, your other folks will follow. And how we incentivize change them. People need roles and not jobs. So we need to continuously work in our organizations to improve the people side of it. The people side is going to be our hardest challenge. But we're going to talk about some tooling, and we're going to talk about the process as well. So when we talk about the DevOps process, we have the planning phase. We need to plan what we're doing. Then we go into the development phase. Then we're going to deploy some stuff. And then we're going to operate what we're doing. I was working with a UK-based customer the other day, actually it was a couple months ago, big manufacturing company that does cars. I won't tell you which one. And they're like, we're doing all the DevOps. We have everything automated from planning all to delivery. And I was like, great. How are you monitoring what's going on? I'm like, oh, we're not. How do you know how you're successful? How do you know when you have an outage? How do you know, how do you mitigate some of the issues that you have in your organization? They're like, oh, we haven't thought of that. So they had 3 parts of the puzzle, but all 4 of these elements are really critical. Now, writing a process is easy, following it is a lot harder. So I want to talk about sources of vulnerability. So we know that human error is one of our biggest issues. We know that 95% of cloud breaches occur due to human error. 95%. Not your cloud provider, it is us, the humans, right? We screw up all the time. I like talking about Uber, and ironically, Uber had an outage for me again the other day. They had a breach. Does anyone in the audience know how Uber had their breach? What they did? So the one I always give an example of is Uber in 2017 left a plain text password in their GitHub repository, their private repository. Now, anytime you submit code with passwords, it is there forever. It doesn't go away. Delete the pull request, delete the code. The history is there. There are tools out there called Trufflehog. They will find every single one of those passwords in your repository. Don't put passwords in your code, right? So Uber did it. That was cool. That cost them millions and millions of dollars. Plus customer trust. They lost that customer trust. That was actually probably the worst part, because not only did it cost them money to remediate it, they then had to deal with us, the consumers, going, I don't want to use your product. They had another breach recently. Guess what? Password in a PowerShell script. It's not PowerShell's fault. The light bulb that was writing the code exposed a secret. And someone found it. So they also use some other social engineering to get to that password, but don't put passwords in your stuff. So the remediation to fix these things are more cost effective in the development phase. So when we talk about DevOps, we do this thing where we say shift left, do everything early and often. We want to start secure and we want to stay secure. So this is not a security conversation, but a lot of things I'm going to talk about with code need best practice, and we need to start day one. You can't start this process of learning infrastructure as code and going, yeah, I'm just going to put all these passwords here and deal with it later. Because if you submit that code, you have record of those passwords, and then you'll be Uber. Don't be Uber. So we want to fix these things early in the development lifecycle, because the cost it takes for us as developers to find these issues and to remediate them is less than what it costs our organizations. And I still want to have a job at the end of the day. If we have time, I will show you some of the tools. Did you guys see some of the tooling in GitHub Advanced Security on push protection or anything? Okay.
Some code scanning and some.
Yeah, there's code scanning. There's also, if I get time, if so, you remind me about push protection, okay? I will work that in. I will do my best. So I want to talk about this epic deployment. So remember, it took us 4 days to deploy a server in my old organization, which was a blast. Let's talk about our epic deployments. How many of you deploy big feature updates every 6 months to your applications? I like the no head in the corner, but does anyone still do that? How many have done that in the past? Yep, okay. We've all been there. Bank holiday weekend, twice a year, all hands on deck situation, right? We're going to update our code, we're going to have our infrastructure updates, and we're going to go forth and we're going to cry all weekend. But these are complex situations. They're very stressful, The business notifies their customers, and the customers aren't happy. And I was actually speaking to a gentleman in Austria back in June, and we talked about infrastructure as code and DevOpsy things, and he's like, our customers don't like updates. Every time we push an update, they get upset, so we can't push updates. I said, no. They love new features. They don't like how you break their application every time you push a feature. And he went, yeah, you're right. So these big, complex situations are not good. Whether you're delivering your, quote, value to an internal part of your organization or externally to customers, these are risky things. They're non-repeatable, and every time it's different, right? All the services are going to go online, and this isn't reproducible. And we always have retros. How can we do it better? Oh, let's document these things we found out. But we're constantly trying to do this. But the biggest risk in these big epic deployments is a lot of your developers wrote stuff 6 months ago. Who remembered what they ate for breakfast yesterday? I don't. You want me to remember the code I wrote 6 months ago? Absolutely not. So by doing smaller, more incremental changes, we prevent this. So this is where we have the continuous delivery model. So when we talk about infrastructure as code, we want to deploy things often with small incremental changes. We're going to do code commits. We're going to put our things in source control using Git. And that's where GitHub comes in. We're not going to go into too in-depth on that. We can test our code before it deploys. We can protect our environments by putting in testing in different environments. We can have QA, production, pre-prod, et cetera. And we can have identical environments to prevent this big explosion every 6 months. And the feedback mechanisms are really, really critical. If we know something doesn't work, we know early. We can test our deployment completely from end to end. We can test things from when we write our code. Is our code even good? We can run unit testing. We can then also run end-to-end testing, right? And then historical records. We need traceability. And the big thing about infrastructure as code and source control is having that traceability from end to end. Why? Because we need to know how and why something broke. We need to revert it. So if I find my issue in the development phase, it's going to cost me less money. I'll still have a job tomorrow versus the production phase. Because we've all had it. We've had an outage, and you're like, right, who did X? And no one wants to admit that they brought down the entire system, do they? So having that historical record, we make these small incremental changes. We can know, oh, look, I made a mistake. Now, I want to just point out the human factor in this. When you run retros, you need a blameless post-mortem. If somebody makes a mistake in your organization, this is why we want to find it early. We want to encourage that as growth, and that's the DevOps mindset. So if we're going to move to this continuous delivery model, and we're going to have historical records of commits and everything else we did with our code, we need to say, hey, so-and-so, I found an issue in your code. You don't point fingers at them and bring them down. Use it as a learning experience. The way I like to think of it is, you've had that person sitting over your shoulder going, when's this feature going to be out? When's this feature going to be out? And you're like, never, go away. We don't want that. We want to encourage growth and not limiting their behavior. So this is kind of part of the growth mindset where we say to people, yes, we can see what commits you have, but we use them as learning experiences. Where did we make our mistakes? Let's find it before it goes to production. Whereas someone going, you need to finish this or you're out of job tomorrow. We need to change that mindset. And that's why the mindset change is really critical in our organizations. So we're going to talk about infrastructure as code. Who's ready for that? That's what you're all here for? Cool. I want to set the stage with DevOps. Why? Because it's important before we just talk about the tooling side. Right, infrastructure code is the management of infrastructure, obviously, in a descriptive model using version control to store the files. Anyone have any questions about that definition? Pretty straightforward. Cool, nothing crazy. I like to talk about pets versus cattle, right? This is Titan. He's my 69-kilo Great Dane. He was shipped over from America. Long story. I inherited him. He's my pet. I feed him. I walk him. I give him hugs. We talk to each other. He helps me write code. He's my pet, right? The old days of servers, we used to feed and water our servers. We would name them. I worked for customers that would name their, when I lived in Boston, Massachusetts, and worked for another MSP, we would name them after beers, because Boston's known for their beers. Believe it or not, Americans have good beer, okay? Don't judge us. Or another customer named after types of barbecue. We fed and watered these, and everything was needed to be up 24/7. If something broke, we would spend hours or days trying to remediate the situation. Now, we treat our environments like cattle, okay? We don't name our servers. We use some kind of naming convention that is accurate to what it is, maybe like front-end 01, front-end 02, web 01, web 02, et cetera. And even you can put the environment name in there. Naming doesn't matter. We don't feed and water these. But basically, we need everything up 24/7. If something breaks, we rebuild it. And that's where infrastructure as code comes in. Really great example of how I did this with a customer. There is a published case study. I can now talk about it. A lot of the stuff I do is under NDA with customers, but once it gets published, I'm happy to share this with all of you to see how we utilize this and give you more information on how we solve the customer problem. Audi Volkswagen had a physical computer sitting under a desk in Germany. And under this computer, they had to run all their simulation software for their cars. One computer, 300 developers. It took 12 hours to run a simulation. Now, let's point out all the things that are wrong. Single point of failure, no backup, no DR, 12 hours to run a simulation, and 300 people need to use it. Sure. So my team was brought in as the engineering team, and over 6 months, we ripped apart the application, understood how it worked, and rebuilt it and refactored it for the cloud. Now, a lot of things came out of this. One is the application vendor said, we don't support the cloud. But they allowed us as Microsoft to come in and refactor their app to make it work. There were limitations, and I have tons of case studies and blogs about the limitations we faced in terms of licensing, and there is always a workaround. There is always a workaround. But effectively, that single box turned into a VM into Azure. Within 6 months, it turned into a hub and spoke network. So the hub was the licensing server that couldn't change, a few other items, and every time a developer needed to access this application, we spun up a whole new environment as part of the VNet, so like an arm, if any of you know what the hub and spoke model looks like, a spoke, or like an arm of an octopus. They ran the simulation software in 2 minutes, and then it powered down. So what we did is we used infrastructure as code to scale up the environment through a pipeline. They did their cool thing on their side, scaled it down, and it was gone. So the cost to the customer was minimal, just for the time the VMs were up. And it had to be virtual machines, unfortunately. But we then ended up containerizing the whole environment, but everything scaled. So we literally spun it up when we needed it, spun it down. So when infrastructure and things need to run 24/7, it is a different story. But we start using infrastructure as code as a way to scale as well. We use our location, our geolocation, our regions. Great example is some of the code we're going to look at. You can see we put in a region, West Europe maybe. Maybe North Europe, we just change that variable, right? And our variable goes from West Europe to North Europe. We just redeploy it. And we know our DR situations, we redeploy our servers. We don't need to have all this backup, well, we need backups, but our DR plan changes from having stuff on 24/7 in another location to be able to spin it up with infrastructure as code. So infrastructure is code, okay? We do want to store things in code repositories. How many of you do not use a code repository today? That is the amount of hands I like to see. That is 0. I do work with a lot of people with automation that don't use source control. So I have to then go into the source control discussion and why we need it. We want to be able to lifecycle our code, okay? We want to be able to continuously integrate it and continuously deploy it. We call that CI/CD. And when we lifecycle it as well, we have the ability to version it, right? And we have collaboration. We increase our collaboration. So this is the people problem. I wrote something in some code, and I go on vacation. Who can access my code? Who can execute it, et cetera? Or someone wants to change my code. We've all had it where someone's changed our script. We need it in source control. We need to version it. We need to know when things have changed, why things have changed. We need to be able to scale it. Like I said, we change the region our things deploy to. And then governance. So whenever customers say, oh, we can't use the cloud, it's not secure, or we need to govern X, govern Y, we have full traceability of what we're deploying and how we're deploying it. So we know what our gold standard is that we need to deploy with. We put it into a template, and we deploy that template. So I'm going to talk about all the different tooling, kind of. These are all the things that we talk about in terms of infrastructure as code in Azure. There are other things out there as well, but I want to differentiate infrastructure as code tools versus state configuration, et cetera, and that's why these are up here. So how many of you have deployed an ARM template in the past? A couple of you. How many of you enjoyed deploying an ARM template? Okay, good. I don't either. I hate ARM templates. I won't be nice about it. I hate them because they break, things go wrong, and they make me cry myself to sleep. But ARM templates are Azure native. That was our templating version written in JSON when Azure came out. Fine. Microsoft took the hint, and we developed something called Bicep. Bicep is awesome. It uses TypeScript as its backend language. Why does it use TypeScript? Because TypeScript is the most heavily used language across the globe. They considered using PowerShell as its base, but actually TypeScript has the greatest popularity globally. So Bicep actually has ARM templates underpinning it, but you really don't have to touch JSON anymore. Bicep still has some limitations, so we're going to talk about Bicep today. We're going to do a little Bicep-y thing and some ways to get started and some tooling on that. And then the Azure CLI. The Azure CLI allows you to open up Azure, open up a CLI, and do things, whether you're working with Bash, PowerShell. There's also Azure PowerShell, which is a different version of PowerShell. It's great, it's built in, and all the features and packages you need are in the Azure portal, so it's pretty easy to get started with. Next up, we have PowerShell. How many of you use PowerShell? I'm a big PowerShell fan. So I have a video coming out. I'm going to do shameless self-promotion. So Microsoft Ignite is next week. It is Microsoft's largest flagship event. The PowerShell team do not have a session. Yeah, oh. So a couple weeks ago, we recorded PowerShell Unplugged. And we have the newest features and some kind of like the hidden stuff you probably didn't know PowerShell did in a video. It's about 2.5 hours. I edited it yesterday, sent it off the team to approve it. It should be coming out soon. There's also more PowerShell stuff coming down the pipeline because I love working with the PowerShell team. You want to talk about the greatest group of human beings I've ever met. These folks are it. And getting to hang out with Jeffrey Snover is like, well, he's left Microsoft now, but yeah, these folks are great. So PowerShell, great tool. You can automate so much in an infrastructure with PowerShell. It's a hugely popular tool. I talk about PowerShell as being cross-platform. How many of you run Linux and didn't think you could use PowerShell? You can use PowerShell in Linux. It's cross-platform. It's also open source. So I'm not going to go too much into PowerShell today. But yes, if you're using Linux anything, it is open source. You go to the repo, get sample code, start working with it. It runs on Linux. The video that I have coming out actually addresses that as well. We talk a little bit about PowerShell 7 and its capability to be cross-platform. I'm not going to go too deep into that today, but if you want more info on it later, I can send that out. We're going to talk about Terraform, a declarative language. Terraform's my friend. I'm a HashiCorp ambassador. Terraform was the easiest for me to learn when it came to infrastructure as code. Why? Because it uses Golang as the back end, and for me it was just readable. I got it. It clicked. We were good friends. The other thing that Terraform does is let you plan your deployment. So we're going to go into Terraform in a little bit. I've also done some work with Pulumi. Pulumi is great because if you're a developer and you work in a language, maybe C#, F#, TypeScript, Golang, and Python now, you can code with Pulumi. And you use the native testing tools that are built into that language to test your Pulumi infrastructure as code, which is pretty cool. The limitation to Pulumi is if you don't know a language, you're kind of stuffed. But I did work with some gentlemen lately on a project to use the Pulumi, hook into the Pulumi SDK using PowerShell actually as well. So they're expanding the language you can use with Pulumi. So if it's a native language, you use those testing tools. And then Chef, Puppet, and Ansible. I'm going to group those three together. You have to maintain an infrastructure to run those three services. Again, if anyone here has not gotten my aversion to running infrastructure all the time, that's it. But they maintain state. So not only do they deploy your infrastructure as code, they also maintain the state of your environment really well. Now, Ansible actually is a great product. I haven't worked with Chef and Puppet in a long time because you're required to use their languages. So you got to learn a whole new set of languages. So when you're talking about tooling and you're looking going, wow, there's a lot of options here, the answer is it depends on what your organization has its needs for. Ansible is a great tool. It manages state. I have a lot of customers that use Ansible in hand with another tool. But you do have to maintain that infrastructure. But Chef and Puppet use their own language. And it's another thing you have to learn, which is really, really difficult for people. And then we're going to dive into Terraform now, I believe. Yes. So Terraform. The reason why I love Terraform, it's an open source tool, and open source is cool. And when it first came out, it was the first of its kind where you could write, plan what you're going to do, and know what was going to happen before you deployed it. Because never in the past have I known what was going to happen, right? I pushed the big red button, something got deployed, and it broke. So the other cool thing about Terraform is it's multi-cloud, and that's going to be a theme that you'll hear me say a lot. When you're working with Bicep or ARM templates, they're Azure only. Now, Bicep is trying to get an extension in that would allow you to manage other infrastructure. That is coming. I don't have a date on that. I know it's been in the pipeline for a while. But Terraform supports AWS, GCP, Azure. Now, I know I work for Microsoft, but the reality is almost every single one of my customers is in GCP or AWS or on-prem. So if you need to learn a kind of a new language, Terraform's pretty easy. The learning curve on it's really low. And infrastructure folks tend to like it. Developers tend to like it. And then if you're managing different types of infrastructure. So you can hook in your provider. So there's a few items down here that are really small. I do apologize. VMware's in there. So a lot of customers that are running VMware on-prem and in another cloud, they can use the same. You have to rewrite, pull in the providers and rewrite your code. You can't use the same code, but it's the same code format. So it's an easier learning curve. So that's where Terraform's come in. Now, Terraform's owned by HashiCorp. HashiCorp has a ton of other products that they try to sell you as well. So Terraform is free. It's open source. You can contribute to it. Now, the one problem with Terraform is that when it came out, you didn't get day zero support in Azure. That was a big issue. Good news, it's possible now. There is a product called Azure, oh shoot, what do they call it now? I forget the name of it, I'm sorry. But you can hook into the SDK and get day zero support on any Azure component, because the providers are all written by community folks. They're maintained by Microsoft and Hashi, but at the time there wasn't day zero support. There's now day zero support. The other issue that we had with Terraform is if you had existing infrastructure, how do you import it into Terraform files? There's now something called Azure Terrafy. I will show you all that in a bit. You can import your existing infrastructure. Yeah, I know the naming, I'm sorry. I heard a rumor they're gonna change the name because so many people were like, Terrafy, really? Again, I don't work on the marketing side, I just do what I'm told. But the product is awesome. There's still some limitations in it, it's still in preview, but we have a lot of people in the community using it to say, right, I have this whole infrastructure, I wanna import them in and get it into write my Terraform code with it. So on the left-hand side is an ARM template doing the exact same thing the right-hand side is doing. The right-hand side is in Terraform. Which one do you prefer? You can shout it out. Well, okay, sorry, this is actually a bad example. You're right. This is like 50 lines of code. This is like 300 lines of code to do the exact same thing. So we don't like measuring things in lines of code because what might take me 10 lines might take you 5 lines, right? So not a good way to measure our developers, but for simplification purposes, yeah, I'm sorry, this used to have I thought had a thing with, that's like 300 lines and that's like 45, 50 lines. It's a lot simpler to do the same thing. Also, it doesn't break as much. It's easier to read. You get an infrastructure person who's never touched code in their life and they go to read this. They're like, okay, I got to figure out JSON. Really tough learning curve for a lot of people, and that was the struggle. So how does Terraform work? Terraform's pretty easy. You write your code. You hit Terraform init. I was up in Scotland. I went init. That's the best British accent you're going to get out of me. I'm sorry. But you initialize Terraform. And you type in Terraform plan. Terraform plan then spits out, hey, you're going to deploy these things. It tells you how many resources you're going to deploy, what's going to change. If those resources already exist, it also tells you that. It runs a check. And then it spits back with any changes that you're going to have or not have. This was the first time I'd ever seen this in an IAC tool that worked really well. So when you talk about governance and having that record, I have had customers export their plans. The other thing we've done is if we put into a CI/CD pipeline, we run plant, it has to hit all the checks, or there has to be a visual check, et cetera. Each customer is quite different, but they could export that plan for governance reasons as well. Then they had full traceability. Then you hit Terraform apply, it deploys your code. 3 really easy steps. This didn't exist before Terraform in this kind of model for a really long time in Azure. And then we have Terraform destroy. So you can destroy whatever you're doing. So I told you about Audi, Volkswagen, and their server that they had. We used Terraform. We initialized, we planned, we deployed. Really simple. It was a little bit more than that, but pretty simple. And then we just destroyed it. And Terraform destroyed that infrastructure. So we didn't have to pay for the costs, which was really good. So we didn't have lone resources hanging out in Azure. So I'm going to talk a little bit about Bicep now. There's a lot of words on this slide. You can ignore most of them, and I do apologize, they're a bit small. Again, I talked about Bicep, and this originated because we wanted to find a way to find a better language for our customers at Microsoft. We listen. Microsoft 20 plus years ago, if something broke, you called someone on a phone in another country at 3 in the morning, and they'd help you fix your issue, but they didn't care. They had no empathy. They had no reason to have that value with you as a customer.